Hello students, welcome you again in the online classes of Physics Part 1 or the course B.Sc B.Ed and college, second promote B.Ed college at Susta, Muzaffarpur. And I am going to start today the unit 3 and the first topic is second differential equation with variable coefficient. I think we might have studied the starting unit 2 units. Okay, so I am going to start unit 3 second differential equation with variable coefficient. So let us start. So first of all, you will have to know what is second differential equation with variable coefficient. So as the name suggested, in which the differential equation is of second order and having variable coefficient. There is another thing apart from variable, there is constant coefficients questions is also there, but we are going to discuss today only variable coefficient. So what will be the standard form for this equation? For second differential equation with variable coefficient, actually this is second order differential equation with variable coefficient. Okay. So what is the standard form? So you can write down a standard for second order differential equation with variable coefficient. Okay. So the standard form is there, d2y upon dx square plus p dy upon dx plus qy is equal to r. So this is the standard form of the second order differential equation having variable coefficient p, q and r. Where p, q and r are functions of x. See, there is two things here, two functions is there. One is x and one is y. So x is called dependent function and y is called independent. So p, q and r, which is the coefficient of this equation, this is the function of x only, not of y. Okay. So, to solve the differential equation of the second order with variable coefficient, you know the methods. Which are the methods being used to solve second order differential equation with variable coefficient? So, you can write down. You can write down. So following are the methods to solve this equation. there are basically 4 to 5 methods to solve this type of equation. So write down A. When an integral of complementary function that is called CF is known. This is the first one. What is second one? Second one, removal of the first derivative. What is third one? Third method is change of independent rectangle. Change of independent variable. What is fourth one? That is B. Variation of parameters. Variation of parameters. Variation of parameters. And last one is operational method. Operational. So these are the 5 methods to solve the equation of second order differential equation with variable coefficient. Okay, so you can write down these are the methods. But in our syllabus, there is only one method we are going to describe today to solve this equation, that is A, when an integral of complementary function is known. Okay, so let us know what is the method to solve this equation. Okay, so what is the working rule? पहला वर्किंग रूल क्या है कि जो भी इक्वेशन दिया हुआ है उसको आपको स्टैंडर्ड फॉर्म में कन्वर्ट करना है. फर्स्ट वन, कन्वर्ट the given equation in the form of its standard or in the standard form. Pardon, you can write down convert the given equation in its standard form. So how you will convert? Let us see. For example, there is an example. You can see x minus 1 d 2y upon dx square plus x into dy upon dx plus 5y is equal to 3. For example, I have given an example, you can take another example also. So, if you have to convert into, since this is not in the standard form, because the standard form means there should be one coefficient, there should be unit coefficient of the first form of this equation. So you will have to convert so that there should be 1. So if you have to convert x minus 1 into 1, so you will have to divide the whole equation as x minus 1. So you will have to divide whole equation by x minus 1. So on both sides you need to divide. Then you will get like that d2y upon dx square plus x upon x minus 1 into dy upon dx plus 5 upon x minus 1 into y is equal to 3 upon x minus 1. So this is your standard form. Okay? So first working rule is that convert the given equation to the standard form. What is second one? अभी आपके पास स्टैंडर्ड फॉर्म इक्वेशन आ गया. अभी आपको क्या करना है? Second one, you have to compare this equation with standard form. So compare revised or standard form converted. You can write converted equation with standard form of equation and find the value of P, Q and R. This is variable coefficient, so you need to know what is P, Q and R. For example, as far as concerned the previous example, so that was that d2y upon dx square plus x upon x minus 1 into dy upon dx plus 5 upon x minus 1 into y is equal to 3 upon x minus 1. Suppose this is the revised equation which was converted into standard form, so you have to compare with d square y upon dx square plus p into dy upon dx plus q into y is equal to r. So what will be the value of p? This will be x minus 1. What will be the value of q? This is 5 upon x minus 1. And what is the value of r? This is 3 upon x minus 1. So you need to find out the values of P, Q, R by comparing the revised or standard form converted equation with standard form. Okay? Up to here, I think there is no problem. Now, what is the third step? Third step is you need to check out few conditions. You need to check out few conditions of P, Q and R. So what is the first condition? अभी आपको क्या करना है, पी क्यू आर का वैल्यू आपके पास आ गया, तो आपको कुछ कंडीशन चेक करने हैं, और कंडीशन आने के बाद फिर क्या होगा वो मैं बताता हूं। फर्स्ट कंडीशन, इफ 1 प्लस पी प्लस क्यू इज इक्वल टू जी, अगर आपके पास इसका सॉल्यूशन आता है 1 प्लस पी प्लस क्यू इज इक्वल टू 0, तब क्या होगा, दूसरा 1 माइनस पी प्लस क्यू इज इक्वल टू 0, देन तीसरा 1 पी प्लस क्यू एक्स इज इक्वल टू 0, और चौथा एम स्क्वायर प्लस एम पी प्लस क्यू इज इक्वल टू 0, where m is an integer. Okay, then if this condition comes, then what will be the solution? Let us understand. Okay, आप यहां पे जगह खाली छोड़ दीजिए, यहां पे आगे मैं आपको लिखूंगा क्या कंडीशन है। Meanwhile, write down the fourth step. आपको यहां तक छोड़ देना है, केवल आपको कंडीशन चेक करना है, उसके बाद क्या होगा मैं आपको बता दूं, कंफ्यूज नहीं होना है, यू नीड नॉट हैव टू बी कंफ्यूज। इसका फोर्थ स्टेप क्या है? फोर्थ स्टेप ये है कि लेट अस solution of this equation is as y is equal to u into v. So if you have to solve this differential equation, so earlier we have considered that suppose the solution of this equation is u into v, so you have to find out the value of a and value of v, value of a and value of v, and that will be the function of x only. So whenever you will get the value of u and value of v, so simply you will have to multiply this both and you will get the answer. Now please recall the third condition or third step I have told. For the first condition, if 1 plus p plus q is equal to 0, then directly actually there might have some solution or some homework done by the mathematician. They have given a simple trick, you can say. If this condition is satisfied, then the value of u is equal to e raised to x. For any type of equation, if this condition is satisfied, then the value of u is equal to e raised to x. If second condition is satisfied, you will put the value of p, q and find out the value of 1 minus p plus q is equal to 0. Then the value of e is equal to e raised to minus x. This is very important. You need to remember e raised to minus x. If third condition is satisfied, that is p plus q into x is equal to 0, then the value of u is equal to x. The value of u is equal to x. And if the fourth condition where n square plus np plus q is equal to 0, where n is any integer, you can put the value of n is 1 or 2 or 3. If you will get n square plus np plus q is equal to 0, then the solution of u or the value of u has to be considered like e raised to n into x. So this is very important. You need to know that. ओके ये कहां से आया ये छोड़ दीजिए, ये आया ये आपको याद करना है. ओके सो आई थिंक द थर्ड नंबर इज नाउ क्लियर. थर्ड स्टेप इज नाउ क्लियर and fourth already I have given you things. Okay, now point number 5. Point number 5. Or step number 5. What is step number 5? Since you got the value of u by checking the conditions, either of them, then you have to put the value of u in this equation. So put the u from the conditions as mentioned in step number 3 in as mentioned in step 3, you can write on it bracket in above equation. For example, if first condition is applicable, that is 1 plus q is equal to 0. So what is the value of u? This is e raised to x. So y will be how much? E raised to x into v. So this is your fifth step. Okay, this is your fifth step. Up to here I think it is clear. Step by step you need to solve this type of equation. Step by step. You will remember the step, then you will never be able to solve any type of complicated or simple questions. Okay? So now step number 6. Whenever you get the value of y like this, by considering the 1 plus p plus q condition is satisfied, then differentiate above equation with respect to x. So differentiate dy upon dx is equal to dEx into v. So this is the two function. So you have to differentiate that one. So first of all, you need to differentiate first one, and second one you have to take as it is. So v into ex plus ex into dv upon dx. Okay, that will be ex dv upon dx plus v into ex, because differentiation of ex is ex. Okay, now what is the seventh step? And you have to give some equation like this. Now in seventh step you have to double differentiate, you have to again differentiate this equation with respect to x. So differentiate equation 1 with respect to x. So what do we get? d2y upon dx square is equal to d upon dx ex into dv upon dx plus v into ex. You have to double differentiate this one. Okay, now in the seventh step itself you have to solve it more, then you will get some reduced form. So in this equation ex is common, so take it aside. d2y upon dx square is equal to ex as common. Ex is a common, and do not take it. First of all, differentiate. So you have to differentiate first part. So first part means how much? Ex taking outside, so it will be d2v upon dx square, again dv upon dx into ex, because differentiation of dx is ex only, plus differentiate this one, so this will be ex into dv upon dx, and you have to put v into ex, because the differentiation of dx is only ex. Now in each form there is ex, so you have to take ex as a common, and here dv upon dx is also there and dv upon dx is also there, so this will summarize to 2. So if you will take ex as a common, so you will get the equation like this: d2v upon dx square plus 2 dv upon dx plus v. This is d2y upon dx square. Okay, now you have got this equation is equation number 6. Now you have got the three values. What is three values? Y, then dy upon dx, that is part differentiation, and then d2y upon dx square, that is equation 6. So whenever you will get these three values, so put these values in your original equation or given equation which were converted into standard form as mentioned in step number 2. You have to remember each and everything. This step is very important and complicated as well. So you have to memorize the things which is being explained. Now step number 8. Why I am using steps? When you are taking a step, you will not forget. You will not forget or confuse. Okay? So what is step number 8? Put the value of y, dy upon dx, that is first differentiation, d2y upon dx square in revised standard form converted in bracket इक्वेशन. आपको क्या करना है? इसका जो वैल्यू है वो उस इक्वेशन में आपको डालना है. तो आपका इक्वेशन कैसा आ जाएगा? दिस इक्वेशन विल कन्वर्ट फ्रॉम y to v. This is very important. This is very important. For example, we have taken an example. You remember d2y upon dx square plus x upon x minus 1 into dy upon dx plus 5 upon x minus 1 into y is equal to 3 upon x minus 1. So this was the revised standard form converted equation. So you have to choose the value of d2y dx square and dy upon dx and value of y from the step number 6 and 7. So let us see what we get. I think you need to write down from your earlier method. So this equation will convert it into form of d2v upon dx square plus something into dv upon dx and plus in the form of v is equal to something. Likewise, you will get the equation, converted equation, where y is replaced with v. So now you got the equation in the revised form of dv upon dx. Now, in step number 9, consider the value of dv upon dx as z. So if you will again differentiation this, so that will be d square v upon dx square is equal to dz upon dx. Now see what will happen when you will put this value on the place of this, then that given equation will be form a linear equation, something into this one plus something into z is equal to something. So now what will happen? The second order differential equation will convert into linear equation with variable coefficient. Now you have to apply the differentiation concepts to solve the linear differential equation, and you have to calculate the value of z. As soon as you will get the value of z, then again you have to integrate this z. You have to integrate to find out the value of v. So last step is there. That is step number 9. You have to write properly. Consider the value of dv upon dx into z, d2v upon dx square is equal to dz upon dx, and by putting the value of z and dz upon dx in the revised equation, you will get the second order differential equation in the linear differential equation, and after this the final value of z. And step number 10. This is the last step. So in step number 10, value of z, you have to put the value of z, put the value of z in equation dv upon dx is equal to z. You will get the value of z in the form of x, then integrate above equation and find out the value of v. Find out the value of v. Whenever you will integrate this equation, so what is the integration of this? This integration of this differential will be v, because dv upon dx after integrated it is coming to v. So you will get the value of v. So earlier you got the value of u as e raised to x when this condition is satisfied, and now you got the value of v. So this was the main thing you had to calculate to solve this question. So now you got the value of u and v. So now step number 11. Step number 11. Put the value of u and v in equation y is equal to u into v, and that was the solution you considered in earlier step. So you will get the value of y in the function of x only, and that is the solution. And that is the solution, not x in the form of x. And that is the solution. So if you have to solve the differential equation, so you have to calculate the value of y which is independent from differential parts. So these are the 11 steps you need to know to solve the equation of second order differential equation with variable coefficient. Again I am going to explain you in brief. First of all, you have to convert it into a standard form, then you will have to check some conditions, find the value of p, q and r, then you have to make some conditions to satisfy. When condition will satisfy, then you can find out the value of v is equal to ex, and for calculation of v, you have to differentiate the given equation with respect to x 2 times, then you have to put the value of d2y upon dx square, dy upon dx, and y in the standard form converted equation. Then you will get the value in the form of v in front of or on the place of y. Again you have to consider dv upon dx like z. Whenever you will solve this, you will get the equation in the linear order or one order differential equation, and you will have to find the value of z, and as soon as you will get the value of z, you will have to integrate and you will get the value of v, and as soon as you will get the value of v, you have to simply multiply and finally you will get the value of y. This is the final solution to solve this type of differential equation. I think this is very typical, so you need to know all the steps, and by tomorrow I will solve one question that will clarify more and more, and you will get the actual implementation of these steps in the exam. I think this is very clear. In case of any query, I am there by tomorrow also. you can give or you can ask in the comment section. You will get the appropriate answer for that. Thank you very much.